Okay, so Monday today, October 23rd, 2023. Oh, 10/23, 2023. Wow, cool. So it's good. All right, so just recap of where we are in our class progress. Here is our course plan, and we are currently Hmm. Okay. Sorry about that. I just have the phone here and sometimes it rings. Um, is there a... Okay, nobody records. Okay, good. So here, this is where we are in our course progress. We are currently progressing through week number 8. Now, we do have a little bit of scattering going on when it comes to topics, but that's probably the only way I could put things together that actually well, jive together and make sense. Um, excuse me. We are going to get into the world of pipe bending, and that has to do with conduits, and conduits have something to do with raceways. So this week we will cover something that's called conduits and raceways, what these are. We're going to talk about bending techniques, and the bending techniques are going to do with bending the half-inch EMT, which is electrical metallic tubing. And we're going to have to know what the idea of multiplier or the idea of the trigonometry behind pipe bending, what that is. So my goal this week is to introduce you to the idea of the conduits and raceway, and we'll talk about what these are. Conduits basically are raceways, right? But conduits in raceways has a nice ring to the topic. Then we are going to brush or cover some basics of the bending techniques when it comes to EMT. Later on, we're going to after this course, the next course, I think it's called Practical Installations, you will take it well quite a bit further. But if I don't start you up properly on this, you well, you might struggle with it when once you get to the next course after this, right? So pay close attention to what's going on here. Everything that we cover is equally important, but by the Orwell's logic, some mm, some topics are more equal than others. Okay. All right. So I thought maybe I would sharpen your senses when it comes to paying attention in this class. Now, by the same time, we are past the midterms right now, and we have some of us have received the S for satisfactory progress and use for unsatisfactory progress. This is not something that affects any of your mark. However, this is just like taking the temperature of the class. If you see the U, by all means, I would encourage you to talk to me so we can address what's going on and see if I can help you with something, so you don't find yourself in a hole that you can't get out of. All right. So that's about that. You can talk to me. You can send me an email, set up an appointment if you want, or just simply after lecture you can stay over, talk to me, or during the labs, right? So that, all right. So what are we going to start with? We're going to, you know what? We're going to start with conduits and raceways, what these are. And then we're going to try to finish the bending techniques. So we're going to try to cover two topics. Now, also, here is our YouTube playlist, our class YouTube playlist. Please watch this video. It's a 50-minute, almost 1 hour. However, it's 50 minutes out of your life, and it is going to give you a lot when it comes to starting up. So spend that time, watch that video closely. And this is part of the preparation for the lab. All right. So you understand that some of us already have the chance to play with the pipe benders. So that's the one video that really, really I would encourage you to watch. Then here's another 15-minute video before the lab. Hacksaw Basics. I'm going to give you a live demo in class, but please familiarize yourself. The more you know, the more powerful you are with your knowledge. And you know what? The more employable you are. And here's a 5-minute video on something that's called a box offset. We will talk about what that is. And this is just so you could get some sort of a visual readiness when you show up to class, to what actually box offset is, why do we do that, and some of the basics that have to do with creating a box offset, because there is no lab sheets. I'm going to explain everything in class. We're going to make a box offset on both ends of a pipe. So that's the challenge for these next 2 weeks lab sessions. All right. So that's going to be lab, I think it's lab 4. Okay. So enough of that. Let's jump into conduits and raceways. And I'm going to set this up here. Conduits and raceways. There we go. Conduits and raceways. Now, I'm going to jump quickly onto another presentation here. Quickly, that's going to be a quick one slide. All right. We're going to come back to this slide presentation, but I just want to get this definition. All right. What is a raceway? A raceway is a physical pathway for electrical wiring, electrical or signal wiring. So you could just scratch that if you wish, but it's also true. It's also for electrical wiring in our case. But when you do data wiring and signal wiring, yes, you're going to run those wires in raceways. So it's a physical pathway for wiring. Raceways protect wires and cables from heat, humidity, corrosion, water intrusion, and general physical threats. So these are raceways. Each of those conduits is a raceway for a wire. There are many different raceways. They categorized in certain ways, and that's what we're going to take a look at this here slide. So conduits and raceways is the topic for today. Types of conduits and raceways. There are many different circumstances that require the use of conduit or otherwise raceways when running electrical wires. And here is my inheritance from previous professors like 7 years ago. And I left that question on. What are some of those situations that we can think of? Well, since this is an online class, I'm not going to ask you to jump in. However, if you feel like you want to pipe in with voice or with typing in the chat line, go ahead. All right, you're always welcome to do that. The more participation we get, the better the class is. All right. So, what could be the situations that we could use? we could need raceway. Well, we'll talk about this thing a little bit more. However, I'm going to mention a situation. If we are dealing with something that is called a cold air return plenum. What is plenum? When you look up in the class, you see the drop ceiling, those ceiling tiles that are made out of soft material. Above those ceiling tiles, there is a huge space. And in our case, it's probably, I don't know, 6 to 8 feet or something like that. And then there is the floor of the next floor. So our ceiling is their floor. So between the area between the ceiling tiles and the true ceiling above our heads is called the plenum. Right? Now, there are two types of plenums. One is a cold air return plenum, and the other one is not cold air return plenum, closed plenum. The cold air return plenum is, and I'll talk to you a little bit more about that. It can cover the area of more than one room, and those rooms will have somewhere in the ceiling, instead of a ceiling tile, there's going to be just like a see-through grid. That grid serves a purpose of returning the air from the room to the furnace, so the circulation happens. So the air, like for example, the hot air is being pushed in through some registers that are also in the ceiling. And in order for the circulation to happen, the air has to be sucked out of the room and shoved right back into the furnace, and the circle of life continues. Right? Now, the cold air return plenum will have a huge area above the ceiling tiles that is going to have one negative pressure opening, which is like a suction kind of a vent that is going to intake the air from more than one room. So the space is shared. If there is a fire in one above one of the ceilings of one of the classrooms, then the toxic fumes that are going to be produced by the fire through those grids that are basically, instead of the ceiling tiles, that those fumes can enter other rooms. So anything that is being installed there has to be something that's called fire retardant, okay? Fire resistance or fire retardant. So there are two types of fire rated jacketings or insulation that covers the wires. And you might look at the code where that is. I'm going to try to find that later for you. But one of the classifications is called F as in Frank, T as in Tom, FT4 or FT6. Right? Now, if you need to run the wires free air in that cold air return plenum, then you need to have the insulation, the wire with insulation that is rated FT4. Those wires are really, they feel a little bit more brittle and hard to touch. Okay. That FT4 insulation is fire retardant insulation. It doesn't burn as fast, or it's not going to cut. It takes a lot more temperature for that thing to start. So that gives people a chance to leave the room and not inhale the fumes. If you are using FT4 insulation, yes, you can still use that, but you have to have that inside a raceway, closed raceway. You have to have that in the conduit. So that would be one of the situations that you could think of when running wires. Otherwise, electrical wires, it just helps if they are run in pipes or conduits, because that makes the installation have more sense and be more manageable, more controllable, safe, and otherwise, whatever reasons. Right? Okay. Rigid metal conduit. Is that what it is? Yeah, okay. So here is something that's called the RMT, rigid metal conduit. That's what it looks like right here. And the rigid metal conduit is a little bit thicker than the EMT, which is electrical metallic conduit, which will be playing. Is that what it is? Yeah, okay. And those can be threaded, and as the name suggests, rigid, it's more tough than just an EMT. And sometimes it's the fittings that are being used. They can be, well, watertight. However, as I always say, sometimes you're going to install watertight insulation raceways. I always mention that it is very difficult to have a complete watertight system. There's always condensation happening and whatnot. It only takes one weak point for the condensation to enter, and then you don't have this thing watertight. But sometimes you're going to have to install that to give a little bit more water tightness than not. All right. However, those are being classified sometimes as watertight. And you can see here, I'm not sure, oops, here, you can see some of those can be threaded. They could be cut to length, and they could be threaded using those machines that sometimes make noise while we have a class in our big electrical lab, because there's more than one class going on, and sometimes you can hear. So, those threading machines can put on a thread on a cut pipe. You can see those are being bent. Normally, they have a little bit larger diameter for the same classification. So on the outside, the rigid conduit is going to be thicker than just an EMT, electrical metallic tubing, which we will be used to bend. And I'll explain that thing to you when we have this thing in class. Now, here is what we will be using in our class to do the bending. And we'll play with that. Electrical metallic tubing. So RMC stands for rigid metal conduit. EMT, you're going to hear that a lot. So get used to that acronym, EMT, electrical metallic tubing, which is basically a pipe. It's a steel pipe. Now, the one that we have is going to be, is 6 inches. Now, there are a couple of different fittings or connectors that are listed on this page. Now, this is a coupler. Those pipes, usually in the store, they come in 10-foot lengths. So we can cut them shorter. Sometimes you can get them in 20-foot lengths, but you would rarely want to pick that up, because how are you going to transport that? 10-foot length you can throw on top of the roof rack or inside a larger van. But 20-foot, well, it's harder to transport. But sometimes what you're going to have is a run that is longer than 10 feet. Usually, if it's horizontal runs on some of the walls or whatnot, they might be longer than 20 feet. So what you do is you can put one of those in from this side here, tighten the set screw, and the other one from the other, and you just continue running the pipe. So that's a coupler connector. Now here, or fitting, here is another connector. Does this remind you of anything? This, for example, fits the 1/2-inch knockout on a device box. We studied device boxes already. They do have knockouts. And what's on top of that? Oh, there is something that's called a lock nut. So the lock nut is being taken off. This threaded end is going to be fitted into a knockout of an electrical box, for example, or any kind of electrical box. And the lock nut is going to fasten this thing into, make it secure. And then the pipe here goes into this end here, and the set screw is going to, secure that in place. Secure, I use that term loosely. It just so doesn't wiggle or wiggle waggle. It's not something that you can physically consider it as a support. As you can't have it's not designed for the device box to hang off the pipe and consider this thing as a secure mount. Right? It's just so well, the pipe is going to be fixed to the wall, for example, or the ceiling, and the box is going to be fixed to the wall or the ceiling. And this is just so things are nice and smooth for the wires to go through. All right. Next thing here. This is a non-metallic tubing. What do we have here is the well, it's a plastic corrugated type of well, just like the vacuum cleaner hose. Sometimes you're going to use those, but when you use those, there are different types of fittings. I would encourage you to go to any kind of a hardware store. Home Depot or Rona or Lowe's are the biggest ones, but Home Hardware and other hardware stores, they would also have some of that. Look at the Go to the electrical section and take a look at some of the raceways. You're going to find some EMT raceways or conduits. You're going to find some PVC. You're going to find some flexible, non-metallic. This is the flexible conduit. And look at the assortment of the fittings that will kind of be close to where those pipes are. All right. High flexibility conduit. Sometimes you need to, well, usually this type of conduit you would install around not electrical, well, to connect the electrical fittings or connections around the, well, machinery. So this would, most of the time, you would find that in the industrial environment, but not always. You can also have that in the residential or commercial. Although usually, unless it's UV rated, usually this thing would be mounted inside. It provides you, well, greater comfort of installation. PVC conduit. All right, conduit or pipe. They come in different sizes, and so do the fittings. And also you can have PVC boxes. You can bend them to shape. We are not going to bend PVC conduit in this class. We're only going to get yourself used to bending the EMT conduits. In your next class, you will be dealing with EMT, you will be dealing with rigid, and you will be dealing with the PVC conduit. And you're going to have to, in those cubicles that we have, those 2x4 cubicles made out of 2x4s, timber, you will be installing PVC, EMT, and rigid conduits, and maybe some flexible as well. Can you bend these? Yes, you can bend them, and you can use actually the pipe bender that you use to bend the EMT conduits or rigid conduits. Except for this, you have to warm it up so it becomes flexible, and then you well, manipulate this thing into the shape that you want. And in order to join that, you use those fittings that are sometimes prefabricated, or sometimes if you get enough experience, you can use a lot of tricks of the trade to produce those fittings to the shape and length and angles that whatever you want. However, there are a lot of them that you can buy, and you use glue to make them stick together. Usually these will be for the inside installations. However, if you want to use the outside, if you want to use this thing on the outside, you will have to make sure that you're dealing with UV rated materials. Flexible metal conduit. So it's a flexible and metal. It gives extra protection. Some of the BX idea BX cable idea is using the same sort of protection for the cable, but that's a cable that's already enclosed, that BX cable. The BX, come on, armored cable. There we go. So, but this is just the armor, and you can put in this. Usually would put in single conductors, many single conductors, more than one, as opposed to NMD 90 cable, or otherwise called Romex. They also come with proprietary fittings that will accommodate the shape and the type of installation that would require you to use with this type of flexible metal conduit. All right, now this is something that's called a strut type of channel raceway. Strut because it's that kind of a shape. Right? Or this kind of a shape like this. So you have channels. Now, take a look at our classrooms. We do have those installed as a part of the construction. Quite often, what they will have a separator. In one part of it, you will see electrical wires being run, and in the other part would be the communication, telecommunication. It would be phone, data, fiber optics, or whatnot. Over here, it looks like some kind of a multi-pair cable that could be used for phone or intercom. In this case, it doesn't look like it's a data cable, or it could be. It just could be the that type of magnification, and you can see two strands of fiber optic wire. We will deal with this communication wire next time, next semester. Right now, we're dealing with these, but it's a raceway because it's an enclosed way or physical way to run wires. So that's what a raceway is. And this is called a channel raceway because it's got two channels, and it's a strut type because it has that type of a shape. So that's a strut type of a shape. There's also a strut type of mounting rails, which we'll talk about, well, in the next few weeks. Surface mount raceway. See this here? That's what basically what it looks like. Now, this is a big raceway. It's a strut type of raceway. Surface mount. It's a surface mounted strut channel raceway. And see this half here deals with the data wires because you can see the data outlets here. And on top, I'm not sure if you can see it or not, but that looks like a duplex receptacle. So it looks like the top half of that is designated for electrical wires, and the bottom half is designated for the, communication wires. Right? I bet you didn't see that, or maybe you saw it all the time, but you didn't pay attention to this. But now, when you walk into a classroom, when there's a bunch of laptops or computer outlets and that communication structure or infrastructure, I bet you're going to see it now. All right. What did I do? Next slide. Cable tray. It looks like a straight ladder mounted in the ceiling. See, there will be the rails and there will be the prongs. It's called a cable tray. Now, cable tray you can produce out of the strut type of mounting rails, or you can buy prefabricated cable tray that just gets put together like Lego blocks. Now, this prefabbed one costs a little bit more. However, it takes much less time to install this than getting the cheaper strut raw material and cut them to length and put them together and produce that. So some of the, I would say, bosses that send you to work, they might think that they're saving money because here is a strut type of a material here. Strut type of rod. Not a rod, but channel kind of a thing. You can cut this to pieces and you can make this out of it. Some of the bosses do not realize that you're saving money on buying it, but you could be losing a lot more money by having your people who work for you to produce that and then install it, right? So whenever you work for your own projects, when you have to make a decision, well, something to consider. So this is basically a cable tray that is suspended in the ceiling by, for example, over here, see the threaded rods? And threaded rods are also like Lego for grown-ups. So Lego for children is to provide you with some entertainment and you're learning while you're playing. This one here is you use that for work. That's for grown-ups. Right? So threaded rods mounted into the ceiling, and they're holding the wire tray. It's the whole objective of this game is to make wiring nicely organized, because when you have one or two or three wires, you don't have to use a cable tray or sometimes any kind of raceway. But when you're dealing with tens or hundreds of cables, if you don't have any kind of an organized way of installing it, you will never be able to accomplish anything with that. All right. Wireway. Sometimes you're going to have enclosed wireways, so you can close that. And if the building code lets you do that, depending where you are, you could run FT4 insulated wires. The difference between FT4 rated or FT6 rated, there's no difference in the cable specifications. The copper or the way the cable is constructed inside, as far as the copper is concerned, is the same. However, FT6 is fire retardant and FT4 is not. It burns quicker and it releases toxic fumes quicker. So sometimes, but you have to make sure that you can use these closed wireways to install FT4 cables. And in some jurisdictions or some areas, well, you gotta find out what the law of the land is wherever you are. And this is what it looks like in action. Right now, I chose this picture especially to show you because sometimes this thing is so filled up that you can't even close that. So it just kind of defines the purpose of closed wireway. If you pack this thing with the wires so much that you can even close the flap. All right. Now, this is used for electrical wiring. It is also used for data wiring as well. Here's the idea. If you are not using some of the cables, remove that. But the sadness of the situation is that everybody wants to do things quick and get out and get paid. So, okay, well, we're going to have to add a couple more wires. Are we going to pay attention to which wires are not being used? No, who cares? So just keep adding. And over the years, this thing fills up to the point that you can even close the flap. So this is something to watch for. I think the rules are being tightened more and more when it comes to that kind of stuff. So you will see less and less of that unless it's an old installation that somebody did not bother to look or didn't see. Because usually those are in the ceilings. Bus bar. All right. What a bus bar is, it's also a different type of Lego. A bus bar would be a prefabricated module with already wires in it, and you can just connect, and that's how you build the. So this is in an electrical room somewhere. That there are some power wires, heavy power wires going, being distributed to the rest of the building or whatnot. Sometimes when you have a modular furniture, and next time we'll see each other in person, which is going to be tomorrow, make sure you ask. I'm going to try to remember to to get you a couple of examples of how a power bus bar is used in something that's called a modular furniture. Modular furniture is, well, the cubicles. People use computers and whatnot in those cubicles, in that modular furniture, modular office furniture. So the power has to be provided to those. We're not running portable cords or extension cords all over the floor. Those power wires and communication wires go in that built-in raceway in the modular furniture. And sometimes on the bottom of that, a bus bar is being used. So you just get one of the wall of the modular furniture, snap it onto the other wall and snap the connection in, and the wires are already there. Usually that comes with the electrical wires. When it comes to data wires, the other half of the raceway that is already provided in the top, bottom, or the middle of the modular furniture, then those communication wires, data wires, telephone wires, whatnot, they have to be pulled in manually. Is that the last slide? Go on. There we go. Yeah, that was the last slide on just kind of giving you the overview of what the conduits and raceways basically are. Now, we're not done yet. I got a second presentation for you. This is the one here. We got a few slides, and we're going to go through them. Right, we're almost done here. All right. EMT bending basics. One. Right. What do we have here? We have a couple of pipe benders, and some of us already had the experience with that in our class. This one with the blue handle is by Ideal, and the contestants to the left is the orange handled one. It is the Klein one. Matter of preference. Some people like to use Ideal pipe benders. Some people like to use the Klein. They come with two different type of heads on this thing. This Ideal one can have, and in this case, on this picture, there's an aluminum head, or aluminium if you were from UK. Or you could have something that's called ductile iron, which is a cast iron. This one, the cast iron, is heavier, but more rigid. It lasts longer. This is lighter in weight, but it can take few less bumps and bruises than this one here. Now, what we have here in our class, we have a bunch of the Ideal ones with the cast iron or ductile iron heads. And I also have one that I'm going to bring to class. I have a Klein one as well. I just bought it especially for you so you could see it. And this one that I have has an aluminum head. So it's the other situation here. Now, what do we have on this first slide? We have a box, electrical box, and we have a knockout. But notice the knockout is not flush with the bottom of the box, it's raised a little bit. And what we have here is that the pipe that continues, it has to be raised or offset or set off the plane in order to accommodate the proper fitting. So you don't have to just strain and make a ball out of it and just shove it in. Very unprofessional. So that's what the lab is going to be that we're going to do. All right, we already have gone through the definition. EMT stands for electrical metallic tubing. And again, a raceway is a physical pathway for electrical wiring. Raceways protect wires and cables from heat, humidity, corrosion, water, All right? All right, as an electrician, you will be required to install raceways as part of your job. The EMT serves as the raceway for the cabling infrastructure. The ability to bend conduit is a requirement for all electricians. Now, as many different niches, you're going to find that you'll have some favorite tasks for you to do. You're going to favor some things that have to do with this type of job. However, Well, you get paid not to have fun, although you can have fun doing your job. However, you get paid for what is required to be done. So even though you're going to have some favorite things to do or less favorite things to do, well, you need to know them all if you're required to perform on request by the request. Now, some people really enjoy doing the pipe bending. It takes a little bit of practice, but this is done by beautiful master's hands and head, hands and eye coordination, and someone who was experienced and knowledgeable in doing that kind of stuff. It's not easy to do this, but if you enjoy it, if you can do this kind of stuff, well, you'll be that much way more employable than others. All right, EMT, electrical metallic tubing, they're galvanized, which is type of processing that prevents corrosion and other things. But okay, so made out of galvanized steel, but can also be aluminum ones. All right, also called tin wall because this here is a tin, not as thick. All right, as opposed to thick, so it's tin. Different sizes here as well. Right? The EMT is rigid but can bend with a simple tool called a conduit bender or pipe bender. Right? Installed with couplings that we looked already during the previous few minutes ago, that are secured with set screw or compression type of fasteners. Right? The tubing itself is not threaded like rigid metal conduit or intermediate metallic conduit. We don't thread those. Rigid can be threaded, which we will put like a thread so you could screw things on. Common sizes for EMT include half inch, which we'll be working with, three quarters of an inch, and 1 inch. These are probably the most common. For each, you will have to use this size of the pipe bender appropriately. Right? It is commonly used for exposed indoor wiring, runs in residential and light commercial construction. If installed outdoors in exposed location, it must be assembled with special watertight fittings. Right, RMC and IMC rigid metal conduit. We have some of that. I'll show you the difference between something that's called half, is classified half inch EMT, or also something that's called it's classified as half inch rigid, and I'll show you the differences between those two. The half inch is the inside diameter. Now, installed with threaded fitting. See, it's a threaded fitting. So you have to put a thread on that pipe and you put threaded fitting, and that's how things are being installed. Typically used outdoors to provide protection from damage. Can also provide structural support for electrical cables. Once those things, what this means is once those things installed, there will be other trades and other people that are going to be using this thing as a support for their wiring, and they will be zip strapping other wires. Sold in 10 and 20-foot lengths that has thread on both ends. However, you can cut them to length and put your own thread on that using threading machines. Usually 10 feet sections are the most common. Then here's the intermediate metal conduit, thinner, lighter weight version of rigid metal conduit. Approved for use in all the same application as rigid metal conduit. Because IMC is lighter and easier to work with than RMC, it is most common in new construction. It's a new thing on the block. Electrical non-metallic tubing, ENT. That's what it looks like. It looks like a vacuum cleaner hose, right? Flexible, corrugated. Corrugated means looks like that it's corrugated like the throat, kind of throat pipe. Moisture resistant and flame retardant. All right, easy to bend and installs with a snap lock or glued plastic fittings. It comes with all kinds of fittings. Commonly used on the inside of the walls, can be installed inside concrete block structures, can be covered with concrete. Due to the blue color, sometimes it's called the Smurf type. Right, flexible metallic conduit or liquid tight flexible metallic conduit. Here's the differences. Right. You can read this thing here. I'm not going to make you read this. Well, also called as Greenfield because of the name of the inventor. That's what it looks like, spiral type of thing. Gives extra protection and flexibility as well. Um, Standard is used in dry indoor locations. The liquid tight, flexible is if you need some extra protection from moisture and so on. Commonly used with outdoor equipment. This one here, this will be commonly used on the inside to provide heavier units of such as air conditioning. You will see this type of conduit a lot in industrial machinery when you have to connect those. Rigid PVC, polyvinyl chloride, PVC, plastic pipe. Similar to plastic plumbing pipe installed with plastic fittings that are glued in place. Can be bent after being heated. You have to heat it. So using a heat gun. A heat gun is just basically looks like a hair dryer, but don't use it as a hair dryer. Please don't use it. Heat gun produces a lot more heat than a hair dryer. Same shape though. Because of the conduit tubing and fittings are glued together, the conduit assemblies can be watertight. Suitable for different, suitable for direct burial in the ground for many applications, allowed in corrosive environments. So that's pretty good. PVC, rigid PVC conduit. Fittings. Basic EMT sizes, electrical metallic tubing, EMT, also called thin wall. We talked about that. It's a steel raceway of circular cross section, unthreaded EMT. We don't put a thread on those. We just use fittings. Oh, this is a set screw type of connector. And this is a compression type of EMT connector. In both of them, you put the EMT, but you make it secure with that set screw that just kind of makes it tight. And this end goes to the knockout of the box. And over here, same thing. This goes to the knockout of the box, but there's no set screw. You still put that pipe in, and you just turn the ring here, the gland ring, which squeezes this thing. So that's called compressor type of connector. Uh, trade sizes usually go from 1/2 inch through to 4 inches. Okay? Yeah. The outside is galvanized for corrosion protection. The inside has approved corrosion resistant organic coating because well, the wires, you're going to be, in order to pull the wires smoother through the piping, sometimes you're going to be using lube. That's why the lube has to be approved for wire pulling. Do not use any kind of a soapy water. Yes, it's going to make the wires to pull easier, but just think about it. Whatever is in that soap, you don't know. And it can cause a lot of damage to the pipe and to the jacketing of the wires. So that's what's also it's the inside has approved corrosion installed by the okay. So this is this type of set screw or compression screw connector. Okay, what we're going to do is we're going to stop here and we're going to continue in person tomorrow. We just have a couple of slides to finish, and we'll continue tomorrow with the rest of the content that has to be delivered this week. So it's 10 to 1, 50 minutes right now, and we're just going to stop right here. Thank you very much, guys. If you have any questions, talk to me during class, in-person class tomorrow. One more sleep. Yeah, okay. Thank you, guys. Bye. And girls.